All right, Science 20s. Hey, we're going to kind of finish off topic one here. So we've done a fair bit of calculations. We're going to do a little bit more, and then I'll just talk to you very quickly about a lab that's going to be coming up. But this is just kind of wrap some things up when it comes to solutions. There's what they call a standard solution. Now, this is a solution where we know exactly what the concentration is. It's a very precise knowledge that we have. We'll be talking a little bit about this in a lab activity that we do in class. But that's going to be coming up. But you can look at page 46 and complete the pre-lab analysis if you haven't done so already. Now, in this lab, we're going to be talking about diluting solutions. Now, some chemical solutions, when they are transported, we want to transport them in a really high concentration so we can save a lot of money in transporting. If you can concentrate your solution, and then when it gets to wherever it needs to be, add water to it to dilute it, that's going to save you a lot of money. But basically, what we do to get the desired concentration, we may want to add water to dilute it or remove water to concentrate it to give us whatever concentration we want to get. In either case, the amount of solvent changes and the amount of solute does not. So, as a quick example here, you have a 65 milliliter solution of sodium chloride. The concentration is 0.759 times or moles per liter. And we want to know the final concentration if we dilute this to a final volume of 100 milliliters. So let's take a look at what they're talking about here. So they say the initial concentration was 0.759 moles per liter. We're starting off with a 65 milliliter substance. So these are what we call the initial concentration and volume. So you're going to see in the formula we use today that there's going to be initial and there's going to be final. Now, we are then going to add water to it to bring it up to a final solution. And then from there, we determine the final concentration. So what do we do now to get there? So we got this. You look at your data booklet on page 10, and you will see this fun little formula here. That's the initial concentration times the initial volume is going to be equal to the final concentration times the final volume. Now, I just want to just switch colors just a little bit and show you something over here. Also in the data booklet, we know that the concentration in moles per liter is found by taking the number of moles and dividing it by the volume. Well, using this formula, we can find the number of moles by taking the concentration and multiplying it by the final volume, which is what we're looking at here. Now, because we're just changing volume and concentration, we're not actually changing how much solute is in the solution. We're just changing the volume and concentration of the solution. So the number of moles in the initial solution is going to equal the number of moles of the final solution. And since number of moles is found by concentration times volume, we can actually substitute this equation here over here to give us CIVI equals CFVF. Okay, now it gets kind of fun because what we do is we take our initial concentration, moles per liter, and I'm going to multiply it by, now, you may want to convert your milliliters into liters. However, I want to show you something. If we don't, well, and we don't do it for either side, we actually find we wouldn't have to. Okay, because when we look at isolating our final concentration, we want to divide both sides by the volume. And just like over here, the 100 milliliters cancels out the 100 milliliters. We're not canceling out the 100, but we are canceling out the milliliters. So that means to find the final volume, we take 0.759 moles per liter. Oh, already got that. Let me get rid of that. And we're going to multiply it by 65.0 milliliters. We're going to divide that by 100 milliliters. And so the milliliters cancel each other out. If you converted them into liters, you would end up with the exact same value as to what we're going to calculate here in just a second. So on my calculator, I'm going to take 0.759, going to multiply it by 65.0, and I'm going to get 49.335, and then the units are moles per liter. Now, sig digs. Okay. We got 3 sig digs here. We got 3 sig digs here. And we got 4 sig digs here. So number of sig digs in our final answer is going to be 3. So that's 49.3 moles per liter. Okay. So that's a little bit of doing a dilution. Now, this example is just going to find the final concentration of a solution prepared by adding 100 milliliters to the original solution. So our original solution was 65.0 milliliters. There's a few little tricks we want to be careful of in this, because we're talking about adding 100 milliliters to the original solution, whereas in the previous slide, it tells us that we're diluting to a final volume of 100 milliliters. So we're not adding 100 milliliters, we're bringing the volume up to 100 milliliters. So that means to find our final volume, it's going to be the initial volume multiplied by 100, or sorry, not multiplied, added to 100. I'm just going to erase that part there because I don't like that. Just anyways, let's start that over. I can't erase it right now. I'm just going to start over. Okay, so final volume is the initial volume of 65.0 milliliters plus 100 milliliters to give us a final volume of 165 milliliters. So that's going to be our VF. We're still going to use our VI as the 65 milliliters. The initial concentration, what was it on that side? I think it was 0.759. And so going into our 0.759 moles per liter, and then we're looking for the final concentration. Now, I'm going to leave this for you to figure it out, but you're going to do the exact same thing you did on the previous slide, except this is our final volume that we're going to be using. Okay. Now, how much water do you need to add to the original solution to obtain a solution with a concentration of 0.200 moles per liter? Okay, so there's also a little trick that I want to show you here. But let's just start everything out the way we did before. The initial is 0.759 moles per liter. The initial volume is 65 milliliters. The final concentration is what they give us this time. So we're going to be diluting it down to 0.20 moles per liter. And now we're looking for how much water do you need to add? And the key here is adding. We are adding this amount of water. So we're going to find the volume of the final solution, but we're going to have to come back and adjust it to see how much water we've added. So I'm going to come back to that in just a second here. Just want to switch colors. Okay, so CIVI equals CFVF. Original concentration is 0.759 moles per liter. Initial volume, 65.0 milliliters. That's going to equal 0.200 moles per liter, and going to multiply that by our final volume. So final volume is 0.759 moles per liter times 65 milliliters. And we're going to divide that by 0.200 moles per liter. Now I'm going to take my calculator very quickly. I'm going to punch that in. So 0.759 times 65 divided by 0.2 is going to give me 246.675 milliliters. Now, you'll notice this was when we're looking at the units, the moles per liter cancel. So the only units we are left with is milliliters. And again, some people just like to put everything in the same. So they always put their volumes as being in liters. So again, if you're going to do that, just know your final answer is going to look a little differently. It's the same value. It's just the units will be given to you in liters. Okay, so now we are looking for how much we need to add. This is the final volume. We're not adding 246.675 milliliters. We are bringing the volume up to that amount. So to find the volume added, which is really what we're looking for. So this is the important thing, the variable that we're looking for. What we're going to do is we're going to take the final volume and minus the initial volume. So 246.675 milliliters minus 65 milliliters. I'm going to go minus 65, and that's going to equal 181.675 milliliters. Again, sig digs, we need 3. So that means we need to add about 182 milliliters to our solution. Okay. And then again, this one, how much water needs to evaporate from the original solution to get a concentration of 0.890. So again, we're looking for how much water, the volume of water removed, which means, again, you're going to have to find the final volume, and you're going to have subtract that from the initial volume to find out exactly what we're going to do. I'm going to let you guys do that one on your own. We'll probably go through it in class, but give it a try on your own if you haven't, if you missed class or whatever, and then come and see me about it the next day. Now, one last thing, and this is going to kind of lead into our lab because we're going to be working with some acids. An acid is a substance that produces hydrogen ions when dissolved in water to form a conducting aqueous solution. Let's highlight a few important things here. So produces hydrogen ions. Hopefully you know that a hydrogen ion is H plus, and it forms a conducting aqueous solution. So that means these hydrogen ions would be serving as electrolytes. Some qualitative features we need to know about acids. They have a sour taste, they turn blue litmus red, and they produce hydrogen ions. If you eat any food that has a sour taste to it, it's because there is an acid in the food. Doesn't make it dangerous for you, it's just telling you what it is. Okay. Now, when we do this in the lab, it's going to be important that you remember we always add the acid to the water. Acid goes into water. It's A into W. I like think of the teen burgers, A and W. So acid goes into water. If you put water into acid, it can actually make it very exothermic, which could lead to a big time safety risk for us. Anyways, that is all the stuff that we need to talk about. Here's some work that you need to do for the little lab activity we're going to be doing next day. So take a look at that. If you have any questions, again, feel free to email me, let me know. And I look forward to seeing you in our next video where we start topic 2. Good stuff.